Okay, in this video I'm going to solve problem 1 shown here, and we're starting with the set S. So this is the topic of counting. We're going to start with the set S that contains 3 elements A, B, and C, and we're going to calculate the size of the power set. The power set of S is the set of all subsets. We're going to write out the power set showing all the elements, and we're going to write out all the elements of these sets. P0, P1, P2, and P3, and these represent, P0 represents the set of all subsets of S of size 0. P1 is the set of all subset of sets of S of size 1, of size 2, and of size 3. Okay. The power set of S is denoted PS, like this. Sometimes written as P with a subscript S, and it's a set of all subsets of S, and the size of this power set is 2 raised to the size of the set S, and the size of the set S is 3, so it's 2 cubed, or 8. Okay, the total number of subsets of a set is always a power of 2 like this. Oh, now I just messed up my 3. Let's try that again. 2 cubed. Doesn't seem to like me writing it. There we go. Okay, so I'm going to go ahead and write this set of all subsets. And I'm going to start with the empty set, which is a subset of every set. And then I'm going to write the singleton sets. Boy, this is awfully familiar. A lot like the problem I did in another homework video. Those are the 3 subsets with size 1. Here's the 3 subsets of size 2. B and C. And finally A and C. And finally there's one subset of size 3. And that is the set of all subsets. That's the power set. So we've written out the power set, showing all its elements. Verify it has the right number of elements in it, agreeing with the answer. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it does. And write out all the elements of the sets P0. Well, you know what? Instead of writing them out, I'm going to say, okay, look, that's P0 of S. These 3 are P1 of S. These 3 are P2 of S. And this one is P3 of S. Okay? And we know those have the right number of elements because they have 1, 3, 3, and 1, which is, in fact, row 4 of Pascal's triangle. Okay? Okay, so that's problem 1 here. Looks like I got time to do problem 2 in this video. We're going to consider a larger set now, and we're going to hope that they ask us about the numbers of subsets rather than writing them all out. How many subsets does R have? Well, the size of the set R is 6. This is a good way to start almost any problem when you're doing it on an exam, is to write out the size of the set using the proper notation. How many subsets does R have? Number of subsets of R is equal to size of the power set of R, which is 2 raised to the size of the set R, which is 2 to the 6th, which is 64. Notice it does not ask you to write out all 64 subsets. That would be a bit tedious. And then so for part B, it asks what binary number corresponds to the following subset. Well, remember what we do for subsets in binary notation. We've drawn a 1-to-1 correspondence between subsets and binary numbers with the number of binary digits equal to the number of elements in the set. And what we do is 3, 4, 5, 6, we put a 0 or a 1 depending on whether or not the corresponding element is in the particular subset we're talking about. And so you see that this subset, BDE, does not have an A, but it does have a B. It doesn't have the C. It has the D. It has the E, and it does not have the F. And so the binary number corresponding to the subset R of R, BDE, is 010110. And we form a binary number with one digit or one bit, I guess, technically speaking, for each element of the set. And put a 0 if the element is not in the subset, and 1 if it is. Okay, so that's a nice description in words, I think, of this scheme, and that's another nice way of showing that the size of the power set is 2 raised to the power. Okay, I'll stop there. Hope that helps with these problems.